And hello everyone, and this is Grace Huang from Intel Big Data Technology. Okay, and here is another author, Jerry Shao, and since about the budget thing, so he cannot be here. But most of engineer work is done by Jerry. So before my talk, so I just need to highlight all those efforts from him and to make it happen. Make this POC implementation happen in just 2 months. Okay. Okay, basically this is the rough agenda for this talk. And first, I will give some introduction for us, and the second, I will give the problem statement and say what happened, why we need it, and the third one is I will give some introduction about StreamSQL, and also the benefits, and the later I will give some insight and some details for our POC implementation, and also some hello world, some samples, maybe make you understand how to use it, and also the key features supported currently. And the last one is the next step. Okay. Okay. So basically about us, and so we are big data technology in Intel. And we, as Reno mentioned, so we have started Spark work since 2012, and we have several key contributors during the past year. And not only focus on the performance part, as we usually do for for example, the Hadoop and HDFS, something like that. But we also focus on, we also make this make the Spark and also the Spark stack easy to use, and so currently and also in the future, I just listed several items we are working on, and basically it's 2 aspects. I won't go details on one by one, and just give a rough idea. 2 aspects. One is the usability and the operability, and the second is also the performance part. And besides of those. We were partnering with the several big websites in China. So we helped them to build some real-world big data analytical applications by using Spark. So this POC implementation is just the improvement on, based on those previous work last year. And it is requested by one of our customers, especially for the real-time analytical processing framework. Okay, and another thing is I need to take this chance to say thank you and highly appreciate those helps from the community and also the Databricks, and thank you for merging our code, merge all those key contributors in the upstream. The source code, and also especially big thanks to Reno and Michael to help us to go through those POC design and also the POC implementation and give a lot of inputs. Okay. Okay, so let's start our journey. And before that, let's go back to some idea presented maybe last year. And so as I mentioned, we partner with some big website in China to help to build some real-time analytical processing framework by using Spark. Actually, Spark empowers such kind of paradigm in big data very well, but it requires some efforts. And here, I want to repeat those details for this workflow and just to give some rough idea. And basically, it collects the event logs maybe by Kafka, and then all those data will be processed by Spark streaming, and all those data will be stored in memory table. And another work path here is also start from the Kafka, and it contains some certain ETL, and all those data will be positioned to the HDFS storage. And finally, we can do some analytical query by using either Shark, as of that time, and now maybe use the Spark SQL, and to do the analytical query from both in-memory table and also HDFS table. And that is the original idea and what I have done, and you can see the link here is we have open sourced this framework called Southern Rain on GitHub. Okay, and but actually, customer always ask for more. So they ask if it is possible to simplify those building blocks, especially for the up part. Yes, that's quite challenging for us since we have already enabled that those paradigm, and so what should I do? So here comes the answer, okay? So maybe we need to build some data stream management system by using Spark. And from that point, maybe we can just take the stream just like table, and so that we can directly do any analytic queries based on those stream, and that is quite similar to the idea of those table things. So here, so we hope to use StreamSQL to simplify all those things, and actually, I think it is quite aligned with the demos that Ali presented this morning. We really hope to make simple things much simpler, okay? So basically, it is our initial motivation for us to do the StreamSQL, and yeah, it is actually the request from our customer, okay? Now let's take a look at what's StreamSQL. Okay, so what does it mean to take stream just as table? Now here I list just 3 sentences. I think most of you may be quite familiar with those things. The first one is just to create a table, and the table called words, and there are only single column there. It's the word, and the data was stored on the HDFS. The second one is we just do the word counts. And the last one is if you don't need that table, it just drop it, okay? That's the case for the table. Now, so if you have already kept that idea, I mean the guideline to take stream as table, you can see the modification here is quite acceptable. What we've done is just to replace those keyword table with the keyword stream. And now let's go through one by one. The first one, we just create a stream, I mean, for those streaming data, and it is called words, and also single column word. And the difference here is the data source is from Kafka. And so the data will be streaming and again and continuously. And the second one is it's just the same as the before. It is just do the word counts, but difference is this query is based on the streaming data. The last one is when you don't need it anymore, just drop it, okay? So from that example, I guess most of you have already gotten the rough idea about StreamSQL. And basically, in general, the data stream management system is quite similar to the database management system. And it is process those streaming data just like the static structured data in data warehouse. And the only difference here is actually it conducts those queries continuously instead of in a static way. Okay, so let's see one more example to show the benefits of it. So basically, here we listed the code snippet for the Spark streaming, and basically it implements 3 things: create a stream from certain source, and create table from certain text file, and also do something like join finally. But as you all know, although the Spark streaming, I mean also the Spark has already provided maybe enough maybe predefined transformation or action, but it still takes time for you to maybe to learn or to understand that code snippet, right? So let's take a look at StreamSQL. So from that part, I think you can fully understand what happened in there. And there are total 3 things also. The first one is we create a stream called weblog. And here there are certain columns included. One is maybe the visit source IP. The second is the cookie ID for that user. And the last one is the item ID. And we also specify that the data source is from the Kafka. And the second one is we just create table. I think most of you quite familiar with that. And it contains the item ID and also the category name. The last one is we do the mutual operation between those stream and also table, and we just count the visits for each category. And I think it's most straight way for us to understand. I think especially for those Hive user, SQL user, it is very simple and very easy to learn and to understand. So that's why we need to introduce StreamSQL, and that's why we help to make the simple thing maybe much simpler. Okay. Okay. Now let's dive into our POC implementation for this StreamSQL. Basically, it is the building block on top of the both Spark Streaming and Catalyst. So as we all know, the Catalyst is the query optimization framework which supports Spark SQL. And so you can find we use both of them to implement those StreamSQL and in our POC implementation. Okay. Okay, now let's give a high-level idea for its architecture. And basically, its entire workflow maybe is quite similar to the Spark SQL itself, since both of them are on top of the Catalyst. And we have customized those Hive parser and also the Hive AST, I mean the abstract syntax tree, to support some new introduced maybe stream syntax. And after that, we have go through maybe the analyzer and also the optimizer to get the optimized logical plan. And those building blocks are just the same as the Spark SQL. And the only difference here is start from the optimized logical plan. And here there are two branches start from the optimized logical plan. One is the original physical plan for the Spark SQL, and the other one is which newly reinvented for the stream, and we have new reinvented the physical plan for stream only, and then we can convert those stream physical plan to certain dstream DAG, and finally those dstream DAG will be translated to the RDD DAG. So that idea is quite similar to what I have done in the Spark streaming. Okay, so that's the high-level idea for the entire workflow. Okay, now just to give more information for the DDL and also the DML's design in our POC implementation. The first one is DDL design. So as I mentioned, we have modified Hive parser to support newly introduced stream syntax. So you can use the create stream, either use the drop stream. So these things are not supported in the previous Hive QL. And besides that, we have shared the Hive meta store so that you can easily integrate this stream SQL to those existing Hive deployment. And the second one is we just customize some stream input format and output format. And here, the concept is quite equivalent to those Hadoop MR input format and also the output format. So by using the input format, you can customize and you can define your own class to understand the records, how to tell it is the record, and how to tell the delimiter and something like that. And by using the output format, and you can specify the write type, so you can define what's going for those stream output. And so that is the second point. The last one is we also borrow some ideas from the existing maybe Hive ideas to reuse some third and the serialized and the deserialized class to understand the inside of the data structure, inside of each record. Okay, so that's basic idea for the DDL, data definition language part, and now let's take a look at the DML part. So as I mentioned, we have just reused those original logical plan. So that means we didn't do something special on those logical plan, especially for the analyzer and also the optimizer. But what we have done is to build a new physical plane, a new tree for those stream only. And you can see from the chart, I mean from the right side chart, you can see each tree node contains an original Spark plane. I mean in the stream physical plane, and so based on that, it can evolve to a dstream DAG, and finally the dstream DAG turned out to be the RDD DAG essentially. So those concept is quite similar to the Spark streaming, and so that's why we can have it happen. I mean for the StreamSQL, you can run on top of Spark. Okay, so blah, 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 and maybe so boring about it. And now let's see some example and see some Hello World. I think most of you maybe like some Hello World application, means simple and direct way. Okay, and not only for the Hello World example, and I think it can help you to understand some kind of key features supported currently, okay. Okay, so there are still so much details here, okay. But basically, this example is to demo some kind of simple usage to do the HiveQL like the StreamSQL. So there are two sentences here. The first one, you can do something like the create stream, and there are more details here. You can define the raw format and also the info format and output format. Besides that, you can configure the location, I mean the data source, maybe some from the Kafka and some from the socket. So both of them have been supported currently. And the last one is just to do the word count. It's quite simple and maybe quite direct. Okay, so here this example is just to demonstrate maybe for those, especially for those Hive user, you can learn the StreamSQL as soon as possible. Okay, so now let's see the second feature and also the second example. So here, this example is demonstrate some mutual operation between the table and also the stream. And here, I think the query part is quite similar and just like what I have demoed before. But the only difference here is I just want to show how to create a table, how to maybe create a schema RDD without using that Hive context. So basically, you can use the two functions like register as table and also register as stream to create a table, I mean create the schema part. So after that, you can do the query between those registered table and also those registered stream. For example, here we just collect the visits for each category, and so that you can see the top visits here. The total visits here. And that's the mutual operation idea between the table and the stream. Now let's take a look at more examples. Basically, in the following two examples, it demonstrates some maybe Scala and also Spark-friendly features. So the first one is the language integrated query. So based on the previous work, and you can write the where clause just in a maybe a programming language friendly pattern, for example like this. And by using this kind of the program language pattern, you can get some. For example, here you can get the focused category. I mean, to get the visitor for those focused category. For example, the World Cup. I think it is the most popular topic here. And okay, by using that, and you can also get the dstream object. And of course, by obtaining that dstream object, you can also use all those predefined transformation and also actions for the Spark streaming. So it can be easily to integrate existing Spark streaming deployment as well. So here we just use the filter and also the map to filter out all those those categories maybe with less visits, and also to output a format with, output those results maybe with the certain format. So that's the idea behind it. That's the idea for this feature, how to integrate with the Spark. Okay, now let's see those maybe potential feature work. And I think there is just, since our work is just the initial POC work, so the initial POC implementation. So what we need to do is to make it more maybe functionality ready and to make it more mature. And the first thing is the first priority thing is we need to the window function. Since you all know the window function is quite important and necessary for the streaming process, right? And it is also maybe missing in the Spark SQL now. So in the near future, we hope can make it happen in both Spark SQL and also the Stream SQL. The second one is we are considering to have some generic design for the physical plan. Since I mentioned we have two branches, one is for the original Spark SQL, and the other is for the newly created physical plan for the Stream SQL. So for the stream. So we are wondering if it's possible to unify those two branches into one. Maybe the rule-based mechanism is the possible way. And others is, for example, we hope to enrich the DDL operations. For example, we can create the stream as a table. So it means you can copy those table schema to some certain of a stream, and you can also copy the schema from the stream to the stream. And besides that, we hope to support more stream source. Since I mentioned that currently we only support two types of sources. One is the Kafka, and the other is socket source. So we hope to, in the near future, we can introduce the Flume as well. And the last one is the command line interface. I think command line interface is also the ongoing work for the Catalyst, for the Spark SQL. So I hope we can do more things to enable it for the Stream SQL as well. Okay, so that's for the future. Now let's go back to talk and come to the brief summary. So basically, it really requires to do some mining or exploration in a real-time and a streaming manner. And actually, our customer always requests more. So they hope to use it simple and in a direct way. So motivated by that idea, so we have the POC implementation by using the Spark streaming and also the Catalyst to implement Stream SQL. Basically, it is the utility to manipulate stream by SQL language. So we are so familiar with just like table. Okay, till now we have supported four key features here. The first one is HiveQL compatible and also share the existing meta store. So for those HiveQL users, it is quite easy. And the second one is mutual operation, just as I demoed. And you can do some maybe join function between the table and also the stream. And the following tools are just some Scala or Spark user-friendly feature, and you can easily integrate those Stream SQL into your Spark streaming deployment. Okay, so from my perspective, I think Stream SQL is quite lucky, and because of the Spark streaming and also the Catalyst make it happen, and maybe quickly running on top of Spark. And on the other side, the Spark Stream SQL also serve the Spark with easy usage. So we really hope to get more information and feedback from you, and hope to make both of them, the Spark Stream SQL and also the Spark better and better altogether. Okay, thank you very much. So I think still have some time for the question. Okay, yes? actually the question is how to tell the answer and yeah, get the results since the stream is continuously, right? And actually here we just we never say stop for here. We just played this stream pattern again repeatedly. So the output itself is a stream output. So you can feed in those stream output to another pipeline, another chain. So never say stop. If only the stop thing is we need to, yeah, actually we need to add some extra syntax to stop the query itself. Yeah, that's the answer, okay. So, okay, oh, one question, okay. What's? Yeah, actually, yes. This is the simple sample, and actually we support the join between the stream and stream. Yeah, thank you. Okay, I think that's all for. Thank you very much.